So let's take a look at what happens when the energy of the air molecules that are vibrating back and forth go into our ear, and how the ear converts that physical energy into really electrical energy that then gets sent into the brain, and we hear the concept of what we hear as sound. So there's a movie that will show a quick animation which shows sort of how the sound moves into the ear and moves into what's called the cochlea, which has a membrane inside it called the basilar membrane, which vibrates or resonates with the vibrations as they come through. So as this plays, we'll be able to sort of see an example of that. So as we move into the ear, you see the eardrum vibrating attached to the three bones, and there's the cochlea, the organ. If we unfold that cochlea, which is filled with fluid, we see the basilar membrane, and you can see the vibrations as the membrane moves in sync with the vibrations of the sound. A low frequency, a high frequency, and an even higher frequency, all three together. So if we look at this basilar membrane, you start to see different parts of the membrane will move according to the frequency. A higher frequency will generate a smaller part of the membrane. You can't really see in this animation, but along the edges of the membrane are tiny hairs. They're called cilia. And those cilia are each moving each time that that part of the membrane vibrates. When those hairs are actuated, then they send little electrical signals to the auditory nerve, which then about 30,000 of those are all vibrating simultaneously. And collectively, when all of those put together, we hear sound in our brain. And it's important that we have a range of frequencies, because the smaller frequencies you can see are being picked up by the smaller part of the membrane, and then the wider membrane is representing the lower frequencies. Now the membrane, it's important to understand the construction of that, because this membrane cannot represent all the different frequencies or pitches of vibrations that are coming into our ears. So we're hearing vibrations that may be happening all the way from 1 time per second all the way up to who knows how many times per second, maybe 30, 40,000 times per second. There are vibrations in the air. But our brains can only make sense out of around 16 or 20 on some people, up to about 18 or 20,000 vibrations per second. So that's because this organ, this membrane, only has the ability to represent and vibrate according to that frequency spectrum. Now let's go back through this membrane and sort of see what we were looking at again. If we go back, kind of scroll back through this, you would start to see the cochlea. This is filled with fluid, and the three bones that would transmit that. So what we have inside here, it would be like vibrations moving through some kind of fluid, the fluid in our inner ear. And then that fluid is picking up those vibrations, which then start to move that membrane. So inside the ear, we've really converted a kind of a physical energy of molecules, air molecules that are moving back and forth. Those molecules go into fluid, which start to vibrate at the same resonance. And then those get converted into electrical pulses when the cilia start to be activated. So in some ways, our brains are converting a physical energy to an electrical energy. And that's what we hear as sound, which is important, because what we're doing when we're trying to use a microphone and we're recording the sound of a microphone, we're doing the same thing. We're taking the physical energy of the air molecules with a microphone, and we'll be explaining exactly how microphones work in a later session. But the microphone is converting that physical energy into electrical pulses, which can go into a mixer, which we will talk about how a mixer works. The mixer will then send that information to a converter, which actually converts the pulses of electricity into digital conversion. So a digital conversion, as you know, digital language is really just zeros and ones. It's a series of representations of information in that particular language. So once we get it to the zeros and ones, then we're processing it in our computer programs. So it's all about the conversion of sound. It's important that we understand how sound is worked and understand the limitations of the conversion process, because that's where we have sometimes the sound doesn't quite get represented when we convert it. So that's what this course is trying to teach us, is really understand how sound can go from physical to electrical to computer or digital versions.
The preceding program is copyrighted by Emory University.